I didn't do anything yet. All right. Let's see. Who knows the cultural reference behind the title? If I had a hammer, you can bing for it. Okay, you can bing for it. If I had a hammer. Progressist song in the 40s. Progress is the theme here. All right, so static if I had a hammer. Let me start with the punchline, which does not work. All right, let me start with the punchline. Trees. They're good, produce oxygen. Occasionally, you want to have a pointer to the parent. In a tree, it enables certain algorithms, right? So you want to be able to control the structure of a given tree. Assume it's a binary tree in this case. We want to be able to control the structure and enable certain algorithms and capabilities depending on whether I want to pay the price of storing a pointer to the parent or not. It can be done in today's C++ with a lot of aggravation. The proposal would allow code like this to work. Union class with parent, no, comma, yes. Why didn't I say yes, no? Yeah, so no is 0, right? Nice touch, Andrei. All right. You still got it. All right. And then we say, well, let me define a tree which takes with parent as an additional generic parameter. And depending on that, it's going to add some layout, add some data. So we have left child, right child, and we have an optional parent present. We have the payload, of course, and everything. So this will be the state of the tree, and I can get very fine-grained control over the layout of the data in the tree. And then I can have a lot of stuff going on in that tree, and a lot of it can be actually guarded by the static if. If you instantiate the tree with parent yes, as in this case, what's going to happen is you're going to get a tree with parents. A lot of extra functionality is going to be automatically enabled. Policy-based design at its very best. If you instantiate with no, those are going to simply disappear. So this code here is not even going to be looked at by the compiler. It's going to simply vanish, right? Interesting. Another motivating example, rotate, which Bjarne mentioned yesterday. I think it's one of the nicest algorithms there is. I think it was Stepanov himself who figured it can be done with forward iterators only, that you don't need backward iteration or random access, which I think is a nice result. And rotate works on forward iterators. And with the proposal that I'm going to talk about today, you can actually say, well, rotate works if it is actually a forward iterator. So you get to qualify any declaration with a constraint that says under which conditions the declaration stands, right? I'm going to get into more detail about this. But as far as the punchline, this is where we're going with this. So the idea here is, let me actually walk through today's agenda. First, I'm going to discuss a bit more motivation. I hope I've already kind of piqued interest. We're going to discuss the static if declaration, then template constraints, and a few words about implementation issues, after which I'm going to conclude. All right, so a lot of code today in C++ is introspection driven. You look at the properties of a type, and you do something interesting. Or you do an optimization, or you make a decision based on that. And we have a lot of acknowledgement and encouragement of these emerging techniques in C++ already, in C++ 11, by the means of traits, the traits header. The traits header is very interesting because it includes stuff that cannot be implemented in C++. It looks like a regular template, but it cannot be implemented in C++. it requires compiler magic. Examples include has trivial constructor, has no throw constructor, has no throw assignment, and so on and so forth. These kind of properties of types cannot be written from first principles in C++. Usually what you're going to see in the typical implementation of such traits is some underscore, underscore, obscure keyword, underscore, underscore, right? That kind of stuff. So this is sort of a witness to the process of, there's a lot of development in this area. Like there's a lot of C++ code that relies on introspection. We look at types, draw conclusion from their properties, and the code and the layout of data is influenced by such decisions. All right. Then we have the recursive templates motivation. I've had a lot of code yesterday that relied on, let me define the specialization for the termination case of save printf or tuple or whatnot, kind of the empty declaration, and then let me actually write the non-empty case, the interesting case. And this is kind of, it's more than a bit annoying. There's a signature duplication, which can be pretty bulky. And there's this feeling of uncleanliness, which comes from the notion that the correctness of a piece of code is dependent on another piece of code that's not related, that's not there. It can be actually, elsewhere in the module, right? It's quite unpleasant to rely on this in the language. Then we have all this specialization on arbitrary type properties, of which I talked a bit already. And enable if is a sort of a solution to that, but it's incomplete. It's very syntax heavy and has a lot of corner cases and documented idioms. Use it this way with classes, use it this way with functions, use this way with special functions such as constructors and destructors. It's just it's just one complication on top of another. My strong belief is that constraint templates are too important a thing to leave it to a hack. Too important. There's difficulty in defining policy-based designs. Just contemplate for a second here. Just contemplate how difficult it would be to do this otherwise. You would essentially need to specialize the whole tree class, so you end up having two bodies of code, and maybe you're one of the smart ones, and you use inheritance among them. So you hijack a language feature that was not, the tree is not supposed to inherit the tree without pointer to parent. It's not a natural relationship, right? So it forces you into a sort of an entire culture of tricks that have nothing to do with the original intent of the feature, and just for the sake of doing something. Look at it's so simple. It's such a simple thing to want, right? And it's kind of I'm very annoyed by the fact that in C++ we have developed this culture of saying, oh my God, I can do X. But there's sort of an internal joke, because essentially X is a very simple thing. It's just very complicated to do in C++ in particular, right? Like, modern C++ design does only simple things. And yet, they're so difficult to do that essentially unwillingly, people say, oh, so Andrei is the guy who has these template tricks with no good benefit, Actually, I think everything is justified. It's just unduly complicated sometimes. All right. OK, this remote. Last but not least, definitely, there's a lot of opportunistic optimizations depending on type properties. So you're in a function that does some copying of data. And if the data has a trivial constructor, maybe you want to do a memcopy. And Chandler's compiler is going to tell you, if you call memcopy the right way, it's going to say, hey, memcopy, you got to multiply with size of there, right there. So you may want to, whenever you code, opportunistically kind of make a decision depending on the property of a type and write code that otherwise would not even compile. All right, now, the converse would be, why not static if? would you, whenever you have an if to write in your code, would you stop and define a new function? Probably not, right? It's a very fundamental thing to want. Condition. Static if would make advanced library very easy to implement and debug, easy to implement and use, to understand and use. And simple problems, again, should have simple solutions. I want to define a function that works only with numbers. I want to define an algorithm that works only with forward iterators. I can choose whether the tree has parent pointers, as we just discussed, right? These are simple demands, and they should have correspondingly simple incarnations in code. Just to sort of brush a little bush out of the way here, a little pothole. When we talk about conditional compilation, so this keyword is going to come a few times, right? Conditional compilation. Whenever we talk about conditional compilation, pound-if comes to mind, right? Pound-if is not even close to what we're discussing here. So pound-if, the conditional compilation kind enabled by pound-if is completely inadequate for the kind of processing we're talking about it. Because pre-compilation occurs way before any semantic analysis. So the kind of symbols and expressions that the preprocessor is able to look at is a completely separate world, essentially. And it's, the preprocessor cannot operate on genuine C++ symbols at all. And we want to use actually arbitrary Boolean expressions in there. All right, so the basics go as follows. We introduce a new declaration, static if. It's a declaration that can occur wherever a declaration or a statement would be otherwise allowed. Such as you define int x semicolon, that's a declaration statement. And if, static if could occur at top level or inside the function. As a, for the sake of example, we have a bit shift right by 64-bit whatnot, and it's simply guarded by a static if size of size t is 8, right? So we define this function only if we're compiling on a 64-bit architecture. Otherwise, there's not going to be anything. There's no declaration. Or we could talk about saying, well, I'm going to define bit shift right 64 for all architectures. It just so happens that inside that function, I decide to take sort of a native approach here or a conservative slow approach here, right? So in the first case, if it's a 64-bit machine, maybe I have a 64-bit primitive there, intrinsic of some sort. Otherwise, I'm going to do it by hand, again, with a loop or whatnot, right? Well, the tested, whatever the expression the static if tests must be a constant expression of if testable type. So whenever it could occur inside the static assert, the size of an array, so it's C++ very well defines very well what really a constant expression is. So it's an expression that must be evaluated during compilation. And with the advent of const_expr, the set of expressions that can be legally evaluated during compilation has grown to highly non-trivial sizes, right? An interesting detail, the braces do not introduce a scope. So you see those braces there? Here, 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 right? So the braces do not introduce, they are for grouping, not scoping. What do you do if you want a scope? You double the braces, right? You write static if brace brace. Because otherwise, I mean, let's imagine we decided that the braces do introduce a scope. Then it would be kind of useless because I define this function, but it's not visible outside at all. So it would be sort of an exercise in futility to say, oh, so I'm going to introduce a scope here. So yeah, so then what do? You play inside that little playground there, and then you're out of the scope. So essentially, it's very good to have that. However, here you might have some, legitimate need to say, I want to define a scope here and another scope here because maybe I have some duplicate declarations or whatnot, right? So in that case, maybe you want to actually double the braces here. It's a rare but non-zero situation. No, you know, I've seen it happening. All right. So, interesting detail, there's no need for a static else. By the way, I should have inserted the absolutely obligatory joke of, you know, overusing static and whatnot. Probably should have called delete. Delete if. How about that, right? Delete if would have been interesting, but you know, since static if sounds so much better, how about using static? Fortunately, there's no need for static else, so already we're 50% ahead, right? So it saves 50% of the cost here because actually using sheer else is going to work properly. One simple question, what happens when you use together the likes of if and static if? So what if you have static if and then else and whatnot? The same old rules apply. Else matches the last if or static if, right? It's very simple. There's no problem there. All right, and here's the interesting part which I'm going to discuss towards the end of this talk. There's no static, the code on the failing branch is tokenized and stored, but not compiled, not truly compiled. This situation is very similar to uninstantiated templates that may contain semantic errors of certain categories, but the compiler essentially ignores them, reads them, stores them, remembers them, but ignores them if never instantiated. So we have this sort of purgatory for static if conditions that fail, such as in this very case, assuming we compile on a 64-bit system, the else branch is never going to be compiled. It's going to be tokenized, stored, but it's not going to be really compiled. It's never going to be used. This is great because remember, I mean, I'm sure all of us have this frustration. Like if you remove static here, and you do something that would not otherwise compile on the other system, right? The compiler is really, even though you have a constant condition here, the compiler is really adamant about being able to compile both branches of the if, even though it clearly takes only one, right? Okay. Example number 1. All right. Example number 1. Let's say we want to define a sort of a container class. And I intently use 2 static ifs in here. So we have a trait that says debug mode. I can specialize the trait any way I want. I can say debug mode for int is false, but debug mode for widget is true, right? So depending on the debug mode, I define some debug iterators or some fast iterators. Even more so, inside this loop here, inside the debug mode here, well, if the type is constant, then I may make different decisions because in that case, probably const iterator and iterator are really the same thing. So I'm just using a type def there. And otherwise, I'm going to define the elaborate iterator. So we have nested static ifs here. And what I want is for you to contemplate how difficult it would be to you to sit down and code by hand specializations for all of the possibilities that are out there, right? All the 4 bits that happen, right? And this is, it fits on a slide. It's extremely simple. And it's extremely easy for anyone to figure out what's going on. Oh, so if I'm debugging this value, then good, I'm going to look here. It's like an if. I mean, come on, right? Very simple. Again, it shines best when you think of the difficulty of doing such structural manipulation in the absence of this simple device. Even better, an idea that I had this morning was to get pair right, which would go as follows. IsEmpty is already available in traits. In STD, is empty. It's in the traits header. Well, you know this compressed pair business, compressed pair, and we don't like if the compressed pair. We don't like if one of the types is actually empty, which it turns out it does happen. We don't want to pay for the alignment overhead, the padding, the filling, the whatnot, and you would like to compress the pair. Hence, Boost has compressed pair, and etc. actually in C++11 with this proposal, implementing implementing pair in an economic way is very simple. It's extremely simple. All you do is say, well, static if either type is empty, if either type is effectively empty, has no members, and this is another one of those magic primitives, right? Is empty. Actually, no, that can be done from first principles. So if either type is empty, then I can put them in a union. I allocate them at the same address. Why? Because if a type has no state, no members, then there's no way you can write to it anything legally, right? It's legally unwritable. It's untouchable, right? It's a pariah. All right, so in this case, I allocate a union. I put them, I slam them both in the same address, and guarantee there's no harm done. And it all works. Beautiful. No more tricks, no more compressed pair, no more, And the most interesting part here is that you see this dot, dot, dot here at the end. This dot, 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 which actually is the literary dot, dot, dot. If you look very carefully, you'll see that it is in a, I swear it's in a different font. You'll see, so this is ever since my yesterday's talk, dot, dot, dot I treat it differently. It's a big item on my agenda. All right, so then you can proceed and implement. Actually, pair has a lot of little methods, constructors, assignment, move constructors, move assignment. You name it, it's in pair, right? So very nice. With one implementation, we have everything. Oh, I forgot to mention. I said it can be done in C++11 with this proposal because union in C++11 has been relaxed sufficiently for us to be able to do so, even if T and U have constructors, right? Okay. Remember my talk of yesterday? People came to me, they said, Andrei, I kind of liked your talk, but I didn't understand a thing. Which is, this is like the purest form of a compliment. I mean, if you don't even understand, but you like it, I mean, there's got to be something there. All right. So, tuple. Remember we had tuple yesterday, and we had this tuple. We had the specialization for empty tuples. We had the, it was a sort of a white line there, because whenever I said the empty tuple doesn't have anything interesting, it still has. It has constructors with allocators. It has all of these. It goes through the motions of doing stuff, even though it has no state. It does go through the motions, right? It has a lot of little functions that do nothing. The do nothing constructor that takes an allocator, the do nothing copy constructor, that's okay, that's implicit, all that good stuff. Well, in this approach, you just say, well, if size of this is greater than 0, then I'm going to allocate stuff, and else I'm not going to allocate anything, and the rest of it is unchanged. It's shared. Very nice. I love that you can very easily manipulate layout, which is very difficult otherwise in C++, conditionally depending on whatever you feel like testing about the type. It's introspection at its very best, right? Okay. Let me show you something even more interesting. An initialized fill. It's a standard function that takes a chunk of memory represented by 2 iterators. Not chunk of memory. It takes a range represented by 2 iterators, can be anything, and a filler, and fills assuming the data was not initialized. Now, all right. So first thing we do, we have a nice sanity test here. Look at this. So well, if static if the type of the iterator, the category of the iterator is the same as a random iterator, aka the iterator is actually a random iterator, then I can compare the two limits of the range for inequality. I can actually assert on that. I can insert a little check that tells me that this is a sane call. I couldn't do this if it were a forward iterator, for example. There's no less than or equal to for forward iterators and inferior, right? There is for random access iterator only, including pointers and such. So we have this nice little test here, and I plop on assert in there. But then I get I get cocky here Because I say, well, does it have a trivial copy constructor? If it does, then fill and uninitialized fill is the same thing. Whether the data was initialized or not, it doesn't matter, because an int, if you want to write to it, you don't need to destroy whatever it was there because it was just bits. Trivial, right? Trivial means bits, right? So in that case, I'm going to simply forward to my highly optimized implementation of fill, which is quite a trick. You know, we've spent a lot of time at Facebook figuring out what's the fastest way of filling memory. It's not easy, actually. As bizarre as this might seem. This is like really the Neanderthal of computer science epoch, whatever. People are going to look like 200 years from now, they're going to look like at us, they're going to be, oh my goodness. All right. Otherwise, the type must be treated with care. And with care in this case means I'm going to write a straight loop that's going to in place initialize the object by copy, by creating successive copies of the filler. Now, okay, so this doesn't look like a very complicated and very gameful function, but let me put it in perspective a bit. Number one, it fits on one slide. It's a complete function that fits on one slide. Number two, if you wanted to do this without static if, it would be a lot of aggravation because it's the Cartesian product. You need to implement 6 functions because you need to implement for random iterators that have no trivial copy constructors, random iterators that do have the trivial copy constructor. I'm not going to enumerate everything, right? But you get my drift. So you need to write a lot of code, and there's a lot of syntactic overhead associated that you need to repeat over and over again and write little specializations. Again, it's as if whenever you have an if, you would need to go outside and write a different function. It's a huge aggravation. With this, that's it. Let me talk a bit about template constraints, which are akin to static if. They don't use static anymore because it's not needed anymore. And they enable very interesting things. And let's begin that by becoming a bit indignant about uninitialized field. There's an insufficiency about uninitialized field that we just defined because uninitialized field accepts anything. Let me get back a bit. So uninitialized field takes it b, it e, and const t on x, right? There's no relationship that's expressed between, there's no constraint on it. We know it must be an iterator, but it's sort of an implied assumption. And there's no relationship, even more interesting, there's no relationship between t and it. What would be that relationship? Well, it's sort of like I could initialize an object of the type that's referred to by the iterator from a t. So we have this sort of, it's not only a constraint on the specific types, it's a constraint on the relationship between the types. So it's a relation that we need, so it's that it is an iterator and it's also that t converts to star it, whatever that is. This is a known fact. Templates have the tendency of biting off more than they can chew. So uninitialized field accepts a lot of arguments, but then kind of says, oh, I accepted this, but I can't compile it because there's the syntax error inside my implementation. Therefore, any instantiation errors that you're going to have, even though it's your fault in a way as a user of that function, are going to point to syntax error inside the body of uninitialized field. Static assert, planning on static assert inside may help, but it doesn't help you actually fix the problem. It helps to diagnose the problem. All right, there is a solution to this, which we propose in the form of a constraint on the declaration. So we say, well, template of class it and class t, declaration, wait, if condition. What we have here is a constraint on the template that very interestingly imposes a constraint on it, it. It must be a forward iterator. This is a sort of a hypothetical. It's not in the standard yet. So is forward iterator, it's a very useful thing to have. It's not there yet. So we assume it exists. It's very simple to define. So is forward iterator is true, value is true, and is convertible T and the type of star B. Where does B come from? We just saw it on the line before. It's the name of one of the arguments of the parameters of an initialized field. But wait, we can do that. Right? We can do that. There is a template called enable if, which is sort of designed for maximum annoyance because you need to put type name in front of it. So first you need to put this type name. This type name drives me mad because I always forget it, and then the compiler is, I'm not using Clang yet, therefore the compiler is not terribly helpful in telling me what the issue is. So type name enable if is forward iterator and is convertible, and here I gotta take the traits of the iterator and take the value type because I don't have access to this wonderful guy B. I can say decal type star B, right? So even more verbose. And one very annoying factor here is that, for the life of me, I never know how to indent and align these guys to make sense. I swear to God, and this is simple because it fits on slides, but real code, it's not supposed to fit on slides. It's bulkier. And it gets always bulkier and bulkier. And these appendixes here are taking me to the grave. It's just so annoying. All right. So compare with this, and I believe it's too important and too ubiquitous a thing to leave it to a noisy hack. My very strong opinion is that exceedingly few templates must have no constraints. The absolute vast majority of any generic code must impose constraints and assumptions on what it operates on. Every single template must state its assumptions. Every single generic artifact must state its assumption. Must say, you know what, I work on numbers, I work on strings. I work on types that have these properties. If you just put a template there and just leave it at that, it's not fair. Okay? And defining classes too. Imagine we want to define a rational class. So class rational, rationals, you can't have a rational of two doubles, right? So let me put an if is integral of t value. So I'm going to constrain this class declaration only on integral types. Even better, I can actually take a method inside rational and qualify and constrain it. For example, minus doesn't make sense if the underlying type is unsigned. If the condition is not satisfied, the declaration disappears from sight. It's all automatic. So I could have a rational that works with numbers, but if I try to instantiate a rational of uint, unsigned int, and then try to take a minus of it, it's negative, it's not going to compile because where is operator minus? I see someone taking a picture of the slide, which is wonderful. Okay, done? Excellent. Don't take a picture of me, though. I think the slide is much better. Okay. So the aftermath is that the constraint sees the symbols in the declaration. This is important. This is important for two reasons. Reason number one, so remember this thing here, decal type of star B. So we can actually say it's convertible, and I can actually take B because it was just used here. It's very important for the constraint to see actually what the template uses, so it's essential. It's very convenient too because you can actually take the type of things, and actually it's much simpler to manipulate expressions that way if you have access to all the symbols in the declaration. All right. Definitionless declarations may also be constrained. So for example, you could say template of class T, class rational if blah, 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 semicolon. And that's an incomplete declaration. It's not a definition, it's just a declaration. And that would work too. Constraint is not part of the signature. So this is actually simpler than one might think. When I say signature, it's like, the signature of the function, you take an address, the pointer to the function, you take its address, it propagates, it goes with the type as a sort of an addendum to the type of the function. It doesn't have to, because simply, it's very simple. If the constraint is false, declaration disappears. So, it's always true if it exists. It's one of those, Descartes kind of thing, right? It exists, it's true, it can be false and exist. Much like SFINAE. This is the second great acronym invented by the C++ community after RAII. All right. Now, there is a connection with concepts. I want to tread very lightly here because I want to make new friends and stay friends with my old friends. I want to tread very light here. And truth in advertising. We've been using this in the deprogramming language. This feature almost as defined here. And what emerged was that we had concepts. What emerged, grassroots, was we have concepts and we can actually use this facility as a lightweight concept system. Because concepts are expressed as Boolean assertions, so you have a Boolean that says is forward iterator, is copyable, is there's conversion, is this, is that, is the other. It beautifully complements and integrates with traits because traits give you such Boolean building blocks you can actually play with and combine, as we just did in the examples. It makes concept definition as easy as writing Boolean axioms, which we all know how to do. We know how to write traits. It's a known, it's a known quantity. It's very simple. We can express constraints as relations between types, not only individual types. I think this is absolutely fundamental. I think this is a huge advantage that this system has over classic constants, because classic constants actually impose things over one type, whether here you can express constraints over any relation you want across all parameters in a parameterized system. Truth be told, there are constants that say, well, these two types are in this relation. Those are a bit more difficult to define than constraints here. Works with numbers too, not only types. Interesting example. Hash tables, when you have a hash table, it's nice to have a prime bucketing factor, right? It's nice to have a prime thing there, because otherwise there's going to be a agglomeration on the divisors of that number. So it's nice to have a prime number. And maybe you want to have a hash table that has a compile time bucketing number factor. It has the buffer size is a compile time constant. Maybe you want to enable the hash table to work only if that actual constant is a prime number. And maybe you want to prove that during compilation. So it's a property of the number, not a property of any type. It's not a concept. It's a mathematical fact. Similarly, if I want to build a random number generator based on linear congruential algebra, what I need to do is I have 3 parameters. I need to prove they're in a specific relationship. A, B, and M. A must be a multiple of 4. B must be, I forgot what relationship with A, and M must be, I forgot what relationship with both. It's an arithmetic thing. It's not trivial, but it's not difficult either. It's a relationship between 3 numbers. And I want to prove that during compilation that I have a good random number generator. So this is a relationship between numbers. It's not a relationship between types. It's not a property of any type, which means concepts are not going to help me there. I take that back, I'm sorry. Okay, I'm kidding. Concepts don't do that, right? Remember that. Okay. But, and here comes the truth in advertising part. there's no way you can actually do separate compilation with these template constraints, which concepts do. Concepts do that. Because with concepts, you can actually say, I look at a template, it has the concepts guarding it, it has all these good things, and I actually can compile that and prove it that it's going to always work. Whereas in our case, if you forget to put the constraint here, all right, okay. Oh, come on. If I forget to put the constraint here, so let's say I comment out this if and or this if, it's just going to try to do whatever it happens. You know, it's just going to be a classic template. So there's no guarantee of anything. It's just, it gives you the opportunity to enable or disable portions of code without actually proving any property of them. And anyone could, you know, as a theoretician, you wouldn't like to, you know, this is sort of unclean. The experience has said that this particular notion of template constraints has had a huge impact on the D programming language. It's been a relatively new feature, and everybody came out of the woodwork and started using it. Essentially, it's become a staple of D. Implementation issues. Well, there's a big, we're going to have to change the batteries here. We have a big issue here. What happens with the dead branches? So you have an if, static if, else, whatnot. And we have some code under if. We have some other code under else. And you know, the code that does not compile, that's not supposed to be seen, how strongly is it checked? How hard does the compiler squint at it? Right? There are two possibilities that I can think of. Number one, uninstantiated templates. It's a known technology. Uninstantiated templates are parsed up to syntactic correctness. The symbols are looked up, but that's pretty much it. The compiler stops there. There could be semantic errors. The disadvantage with this is that non-portable syntax is not possible. There's always the odd compiler out there that has its own attribute syntax, has its own underscore attribute underscore thing, has its own underscore vector for vector math. And it has things that do not look like straight C++. They look like odd C++. They look like C++ with adornments. And then comes another compiler, it tries to look at the code and tries to look at the dead branch and sees all of these adornments and says, I don't understand this. Even though I'm not going to generate code for it, I don't understand what's happening here, error. So that's the risk. The second option would be to store the dead branch as simply as brace balance tokens. Essentially, all you need, let me get back to the example here. Assuming this is not an integral. All the compiler needs to do in the first shot here, you know, from here down to here, the whole class declaration, the whole class definition, everything the compiler must do is simply, the braces are balanced kind of thing. It tokenizes the thing, strings, literals, whatnot, and these curly braces must pair properly, and that's it. There's no more lookup. There's nothing done. That's a possibility. The plus there here, the nice thing here is that it's flexible, faster compilation speeds because there's only tokenization needed. It's very simple. And sort of a plus and minus thing is that static if or false is going to become a sort of a new way of commenting code. So you have static if false, and then you open a brace, and you put whatever the hell you want as long as you pair the braces. Okay? Which is sort of, doesn't strike me as the most elegant way of doing things. D doesn't do that. D actually takes the first approach. Personally, I'm on the fence, so I'm not sure. We should discuss this during the panel. Either way, there's no built-in way for, as far as this proposal goes, to handle unpaired braces. And the interesting part here is that macros can handle unpaired braces. Macros, what MFC, begin message map. How about that one? Begin message map, opens a brace, and end message map defines a closing brace. The problem with macros that have unpaired braces is actually deeper. All tools that analyze code have huge difficulty, and I hope people can confirm here who actually write such tools, have huge difficulty with macros that don't balance, that are fragments of statements, that don't balance braces and stuff. It's very difficult to look at the code without actually knowing the definition of the macro, or by making certain simplifying assumptions about the definition of the macro, to look at code and say anything about it. It's a difficult thing. So I think this is for the better. I like entities that are, define full-fledged things. I don't like a macro that defines half a statement. As I said, we have used the D implementation as a starting point for this proposal. And it's been defined and implemented and used for a long time in D in the form of static if. So static if has been a long time presence in D. The template constraints appeared later in 2008. Static if has been there since 2005. So the template constraints appeared in 2008 and have enjoyed immediate success. So everybody understood them instantly, and users have loved them. Library writers love them. Everybody loved them and uses them. One nice thing about this proposal is that it's backwards compatible. It allows you to take some code that's all template code. Like imagine you have a chunk of template code, and you can slowly start on using constraints with it, therefore improving its the quality of error messages, its capabilities, and so on, simplifying the code. And as I said, it's very popular with both library writers and users of the language. So it's been a very positive experience. Credits go to the authors of this proposal. It's not really a fledged out proposal. It's a sketchy proposal, not much more than what I discussed just now. So we're looking at Walter Bright, who defined and implemented this facility for D. Herb Sutter, who, after we discussed for a long time during a conference, essentially somebody asked me during a panel, what do you think is the first thing lacking in C++? And I said static if. And then months later, Herb came to me and said, Andrei, I've been thinking of this. I've been losing sleep over this. I lost weight over this. I'm not feeling good over this. So you know what? Let's get this moving. So I'm very indebted to Herb for putting this in motion. All I did was to write the proposal. Walter Brown, not to be confused with Walter Bright, authored an independent, a distinct proposal. Essentially, we didn't know about each other. And Nelson Clark, who's the committee librarian who collects all the proposals, told us, hey, there is this guy who's had a proposal with the same title. And Herb and I and Walter were like, you know what? Let's both run and see what happens. And we both submitted, and then I exchanged email with Walter Brown and said, hey, how about we send each other's proposal now after the fact? And Walter was like, sure. And we sent each other, it's the same thing. His proposal is better argued, but it's more sketchy because, for example, it doesn't include template constraints, which I believe are very important. So there's a lot of alignment, and probably in the future, the four of us are going to merge our proposals into one. With this, it's about time to destroy the speaker. We have 10 minutes for questions. We got Charles. Where's Charles? Andrei, any thoughts about whether static if could somehow replace Herb's #1's preprocessor statement dream? It's a very appropriate question. Static if is not designed for that. You could use it. You could say at the top of a header, you could say static if the symbol is defined. There could be a way to figure that out. And if it's not defined, you define it and you continue. It's not designed for that, and probably pound once makes more sense than hijacking static if for that. There are quite a few questions.
Oh, yeah. Just point where you want people to.
I want STL.
Can you go back to
I want his
slide
head on a
19?
plate.
Slide
Yes.
19? 19?
Slide 9. Okay, he has the slide number.
Yes.
Okay, that doesn't bode well.
Okay, number 1. You mentioned that you can't refer to lowercase b. Yes, you can. In C++11, there are trailing return types. You say
with,
auto and then
arrow
arrow.
decal type.
Yeah, and then you can refer to like decal type a deref b. So static
Yes.
if doesn't buy anything there. You just have to cram that on the right, which looks even weirder. I agree. Then can you go back to 18? This is just number 2. I only got
And
3.
in for the kill.
Yeah.
There we
yeah.
go.
Hey, you asked for ritual speaker side. So I'm wondering, are you proposing sequence points for static if? Because imagine that you call an uninitialized fill with like 5 and 6. And so it is int. Yeah, you know, is forward iterator is false, but then you try to say decal type deref b and you can't deref an int. Now that would work if you had sort of sequence points for static if, where as soon as something's false, then you don't even look at the second part. But all right, I assume that's sort of out of scope, and you would just have to do nested.
I totally understand. So the
Yes.
question
Well,
is,
actually, you couldn't even nest the template constraints because you only get the one shot.
I think I understand the question, but let me know. I understand it at a level. I don't think we need to discuss in terms of sequence points as much as short circuit evaluation of
Yeah,
that.
yeah, that's what I mean.
Okay, thank you. Great. So the question was essentially, whenever you do such evaluation, do you rely on the short circuit? Because if the first guy fails, the question is what happens with the second? Is it looked at all or not? And I think there's actually quite a bit of discussion about this exact issue in D. And at this point, I think we got away without requiring short circuit. I think for C++, it would be actually better to do short circuit because you enter these weird cases. And you know, we kind of know how to do that because of SFINA. We're experienced with that. So I think there's, you know, the jury is out on the short circuit or not. I think it's good to have short circuit though. Yes, in the back.
I'm wondering, in your D experience with templates constrained, did you run into a case that you wanted to actually give a warning, saying that, oh, gee, you called uninitialized fill on T, which is something else, as opposed to just, I have no idea.
Do we have I met the need, have I seen the need to generate warnings as opposed to errors under certain circumstances? D does not have warnings. It's Boolean. It works or it doesn't. And actually, it's very funny. And I'm very glad you asked this because you let me. Where's the soapbox here? The very funny thing about Chandler's talk, which I enjoyed immensely, was that whenever he came with something, I was like, oh, D doesn't allow that. D doesn't do that. D doesn't, you know, that crap not going to work in D. You know that. For example. A simple example, like we have this enum and the switch on enum, huge problem. And he said it exactly right. He said, what if you add a new tag to that enum? So you have an enumerator type and you switch on it, and then you add one more. And then where the hell do you look? It's all over the place. The type is not explicit everywhere. Auto. So then what you're going to do if you add a new enum and want to make sure it's handled? So D has a final switch, literally final space switch, which actually requires all the branches to be handled. So the approach we took in D, we afforded ourselves to is minimal amount of warnings. There's not 0, there's like 5 warnings. Very few warnings, and essentially it works or it doesn't. This is the model, and I think it's a good model.
Right here.
Destroy.
Yeah, sorry.
Works.
Works, okay. So one question I had, first a comment. I also completely agree with you. I only ever build with warnings as errors. It is binary, even though they look like warnings in the slides. It's a binary. thing.
Perfect.
But I had a question.
You do that.
Everyone, please make
Right?
your warnings errors. There are
Yes,
no
warnings are errors.
non-error warnings.
All Facebook code warnings are errors.
Okay,
Thank
so
you.
now a question though. So you initially talked about the fact that static if does not introduce a scope,
Yes.
which I think is, which I like because it means that the declarations are just visible. What about the declarations in the else branch? Because I think this is particularly interesting, especially when you combine it with the question of can you do braced balance tokens, or must you do uninstantiated template rules?
Right.
Because if you want the declarations to be visible, and you want the declarations to be visible in the else branch, and I think you do because otherwise things get very tricky for name lookup very fast, then you can't do braced balanced token consumption because you need to actually see enough of the declaration to be aware that that name is in scope.
This is a great question, and I can see the compiler writer in you. Recall that, where's Walter? Recall that I mentioned that D actually doesn't do the braces thing, and I asked Walter, and he told me that that's exactly why, because the else branch is difficult to detect otherwise. So, because otherwise it may have, it could get just very unduly complicated. So yes, probably that is a very good argument against just using the balanced braces approach. Thank you. Three.
That would be me. Going back to the pair optimization when one is empty.
Yes, I should tell you that this is as long as this is as old as this morning. And this morning I woke up with this huge hangover after last night's party. So, grain of salt.
So regarding this and the code that is in your ellipsis, how does a static analysis tool understand that that value is that T is empty, for example, and to not tell you that you're trying to assign to an empty structure?
All right, so the question is, if I understand correctly, we have here stuff that's going to essentially try to assign to empty values and such. Usually such paraphernalia, there's a lot of type deaths, for example, that are not, there's no context, those are going to work either way. But there's a lot of code that's going to either forward to other functions that are going to just work, or is going to recurse, or is going to sort of take care of itself. I agree that if you kind of take a member by name and just use it, it's not going to work. In this particular case here, if you define an empty struct and then you assign to it, that's going to work. Not going to do anything that is going to work. Do we agree? We agree? Define an empty struct. It doesn't have any state, but you can construct such an object. You can assign to it. You can copy it around. You can do anything as if it did have state. It doesn't, so there's no error there. So I think this stands, actually. So I think this stands as far as your argument goes.
Well, extending that to a constraint that implies other constraints itself, would a static analysis tool be able to
The static
infer
analysis
them?
tool. Would a static analysis tool be able to figure things out? The static analysis tool would need to be able to evaluate such conditions.
But then it would also have to have an implicit knowledge of what is empty really means. Like, is empty implies that it's constructible and movable and things like that. How deep does that knowledge have to get?
Okay, so this actually is, essentially we have struct pair, and inside the struct pair we have a decision on the layout. So I have a decision on the layout, but pair itself could be qualified could be constrained to say struct pair if certain properties of T and U apply. And otherwise it refuses instantiation. So probably that addresses your concern more. As far as tools go, I think any tool that does C++ to an extent would have to understand what's going on there. It should be able to evaluate such expressions because people use them all over the place today. Number one.
Yeah, first of all, thanks for showing me a way to lose weight. So, but I wanted to tie this in with something that we heard earlier this morning. I think Herb talked about introspection, that gets ever more important that actually made me cringe a little. I think this is getting important because all these unconstrained templates that we are flying around actually break introspection in many shape or form. Typically, is convertible will break with unconstructed conversion constructors. So I think we will have to have a better way than enable if, and we probably need it sooner than later.
Right. Was that? There's no question.
There's no
there.
question. All right, so listen, this is what panels are for. You will get destroyed later.
We'll be at a panel. We'll take some questions on Twitter, which I'm seeing some interesting question. Thanks very much.
Thanks, Andrei.
Thank you.